Welcome. Today's part one of our sustainable research training modules. My name is Martin Farley. I work at Green Lab Associates, and I'm going to lead this training for you today. This training is brought to you by FutureNeuro and the International League Against Epilepsy, and they have a climate change commission which have kindly facilitated this training today. Now, I've been working in sustainable research for over a decade now, and have a bit of background in this topic. And I thought the best way we could kick off was with an introduction for why this topic is so important. So I've presented to you a little quiz, and I'm going to give you the answers as we go, but I'd like you to have a think about the answers and just to see what you come up with in the back of your mind. So lab plastics were estimated to contribute what percentage to the total global plastic waste in 2014? Now, keep in mind that lab plastics typically are incinerated at high temperatures. They're not often recycled, although they can be, depending on their levels of contamination and how you're working in the lab. And so I don't know what answer you've come up with, but the answer to this was 1.8%. So our research facilities go through a lot of single-use plastics. I'm sure you're aware of this. Now, I'm based in London, and a London-based university, so one of some of the larger universities, typically spent around £15 million per annum in energy costs. Since then, energy costs have gone up a fair bit. How much do you think they're going to cost this year, and this year being 2024? Now, what's interesting to think is about what percentage of the energy for the entire university is going towards the laboratory and research facilities. The answer here is D. It's well above 25 million. It's probably more towards 40, sometimes 45. And what we do find is that most of the large universities across London, around half the energy are going towards the research facilities. So it focuses the attention. Now, this is a question really about the growth of research. Between 2007 and 13, the world economy grew by 20.1%. How fast did gross expenditure on research and development grow by? I have to admit, when I give out this question sometimes, and it's one that often trips people up, I don't think we're always conscious about how quickly research and development are actually growing by. The answer here is D. It outpaced the rate of growth of the global economy by around 50%, which is really a powerful figure to show how quickly research is growing. This was a question based on citation rates. So I've since found there was another study, but this study was asking how much did scientific output grow by every year? They actually gave an estimate on the doubling time for all of scientific output, which is pretty incredible. I'll give you this answer. It came out at D, 8 to 9%. And if you're an astute mathematician, then you'll have collected that means a doubling time of just 9 years. Now, since then, there's been another Nature study that put the growth rate a bit lower at 5 to 6 rate, but it still shows a very fast rate of increase for research. We're publishing a lot of work right now. So, thank you for participating in the quiz. With this slide, I just wanted to, this is not a perfect methodology at all, but it's to highlight the potential impact globally of research. Now, you can find that in 2022, there was around $2.5 trillion spent on research and development. And the US also publishes carbon emission factors based on spend, which is the most common technique to evaluate the carbon intensity of different subject matters. It's not the most precise one. That's why I'm putting that caveat that this is probably not a precise figure. But they put that at 0.156 kilograms of carbon equivalent per US dollar spent in 2022. Now, if we were to multiply that 2.5 trillion by that carbon factor and then divide by 1,000 so that we can convert it into tons, we would get 390 megatons or million tons of CO2. And if we were to look on this chart on the right, we can see that in 2021, 390 megatons was about the equivalent to international aviation, making research and development by this metric the 17th largest emitter if it were a country per se in the world. Now, again, this is not a precise methodology, but I do think that it highlights the incredible intensity of what research and development is doing in terms of the environment. And it's why we should really consider how we do research and development, how we grow it. And I hope actually you'll find these trainings of use to address that area. Now, I just want to mention one other pressure that we have within research, and that's the availability of resources. Often we convert everything into tons of carbon, and it's about our emissions and the impact that they have on the environment, which is, carbon is the metric of environmental sustainability today. But something else to consider is just the amount of resources we have of specialist materials. Well, I think the best example on here actually is what we see at the top right here, which is the fact that we have less than 100 years really of helium available. Now, if you were to work with MRIs or NMRs, you'd know that liquid helium is used to cool the magnets of them. It's a very highly used atom in research, and the fact that we have less than 100 years is a serious challenge to how we conduct research in the near and especially far future. So we're under some pressures in research to think about the efficiency and environmental sustainability so that we have some continuity to the good stuff that we do. Now, I wanted to highlight this, and this is the one, if you'll allow, I guess, standing on the soapbox to preach a bit about the impact of what we do. But I guess it's important to highlight what we get back for research. Now, if you're likely working on this in terms of health, so you're working in terms of research that addresses human health, which is fantastic. A lot of research also addresses climate change and helps us to be able to understand it to mitigate the impacts, and that's very needed. But I think it was reading through, by the way, a lot of the facts and figures I get are from the UNESCO science report. They do a report on the state of science every 5 to 6 years, which is really fascinating, by the way. Really encourage you to go check out that report. But the report that they did in 2021 was shaped around climate change, which was a really interesting angle. And they were highlighting that not just how we do our research matters, but the kind of research that we do. What are the outcomes of the research? And I mentioned that you're likely working on health, but I think it's something that we do need to be conscious of. I've put here, science is largely shaped by funding in some ways. And it's just keeping that in mind as you progress in your careers in science in the future. The way that they formulated it was that in 2019, there were 147,000 articles on AI, but just 2,500 on carbon capture. And if you've looked on most carbon mitigation or carbon reduction plans at the national or even local level, there needs to typically be some form of carbon reduction, either through carbon capture or offsetting, that allows us to achieve our targets. So we need more investment and more research in these really crucial areas that are beneficial to everyone. Stop there on that. So labs use a lot of energy, and you might have gathered that. As I mentioned, so a lot of research intensive universities, they're using up at least half of the energy. So that's gas and electricity. And you'll find that they use 3 to 5, 3 to 10, sometimes actually 100 times more than typical academic spaces. It really depends what you're doing in them, but most labs will use around 5 times more energy than a typical office space. So to help address this, we have a lot of net zero targets. You can see a list here. There's a list of different countries with their various net zero targets. And actually in the UK, I think it's particularly motivating that one of the largest funders, well, the national funder UKRI, has set a net zero target for 2040. You can see also a lot of universities and research institutions have also set net zero targets, and more are coming on. Now, what does this mean actually, and why, how does that relate to what is going on within a laboratory? Well, I've put here the emissions per person on the left. Those are, it's the tons of carbon per person for different countries. And this is not, again, to point any fingers. This is to give context for the emissions associated with what we do within research and clinical settings. This on the right is an exercise where the International Energy Agency was trying to look at the emissions per person if we were going to get to a 2-degree target in terms of global warming. So right away, you'll notice that the emissions already per person in a lot of countries are far above what we should be at, but that's not what the point of what I'm trying to highlight here. It's not, again, to point fingers at different countries. Keep in mind that figure around 4 tons per person in 2020. Now, these are the approximate emissions associated with different processes for either either a process or a piece of equipment that you'll find within a laboratory. So you'll know that a one-way flight, for example, everybody's conscious about the emissions associated with flights, but a one-way flight from London to New York City will be around 0.6 tons. So if it's a two-way, if you're coming back, which I'm guessing you are, if you're taking a flight, then it's going to be around 1.2 tons. And by the way, that's typically for economy. It goes up if you go up to higher classes within the plane. Fume cupboards use a ton of energy. You'll see around 2 to 3 tons. An ultra-low temperature freezer will consume about a ton per annum. A CO2 incubator, a fair bit less. Drying cabinets can use a huge amount of energy. They're very inefficient. And tissue culturing can use a fair bit of emissions, and that's actually just based on the emissions associated with the single-use plastics and some solvent use. So it's a really big estimate. It doesn't take into account the equipment necessarily used. It's just for the single-use plastics. So, when we add these things up, we see that we have a lot of emissions associated with what we do within laboratory and clinical settings. One of the motivational things that I want you to take away from this is not to be too down about it, but instead to take inspiration that actually, the scope in a lot of these ranges, here between emissions are typically down to the choices that you make. As a scientist or a clinician, you have a lot of potential to save, much more than the average human across the globe. And as such, you should take this away as motivation that actually you can have a really positive impact when you think about how you manage your equipment and your consumables and your chemicals and reagents within your work setting. So, in the next training, we're going to look at purchasing, but I just want to highlight that carbon can be measured about 3 different ways. Well, it's broken up into 3 different categories, and again, we're converting everything into carbon, as you can see, because that's really the metric of environmental sustainability. Now, there are 3 scopes of carbon. Scopes 1 and 2 are essentially the energy consumed. So scope 1 will be gas. Scope 2 will be electricity that you purchase. But as these circles kind of imply, scope 3 is actually the biggest source of emissions. We often consider environmental sustainability around the energy we consume, but the biggest impacts are in the materials that we purchase and buy and our travel. And that is what goes into scope 3. And actually between travel and what we buy, it is overwhelmingly the stuff that we buy that has the greatest impact. So if you want to think within a clinical or laboratory setting, that would be the single-use plastics, the single-use PPE, the solvents, the reagents and chemicals and materials that we purchase and then throw out. And to an extent, the embodied carbon of manufacturing the equipment, not the energy it uses, but the embodied carbon that goes in the equipment and actually, the walls of the laboratories and facilities that you work in as well. So I want you to keep that in mind because that's really how we can have a really great impact and why in our next training, we're going to look at purchasing. Now, these are the overall estimated emissions of 2 major research universities in Europe. You can see UCL on the left and University of Copenhagen on the right. And you can see that, again, this is just emphasizing what I just said, which is that the overwhelming majority of emissions are associated with the materials purchased. Energy, here's the red and yellow, very small. Energy here is around 12%, very small. The way we estimate this isn't perfect, I want to say. Our ability to estimate the carbon associated with energy is more sophisticated in some ways, because when we look at what we buy, we use those spend-based emission factors, which is what I used in the beginning when I was looking at the $2.5 trillion figure for the total impact of research and development. So I think I'm going to stop there, but just want you to walk away from here and remember a few really important things. First of all, research is growing really fast, and the global impact on the environment associated with that research, of course, is growing as well. The type of research you do matters, as does how you do it. And the way that you do it, there's a lot of scope for mitigation, and so that should be a positive thing to walk away from this with. Environmental impacts are typically measured in carbon, so it's our metric. And there are 3 scopes of carbon which we measure, with scope 3 being the greatest impact typically, which is all the stuff that we buy and our travel as well. And of course, laboratories, clinical settings and research are big contributors to scope 3 for higher education and institutes, and it's the same with medical or clinical institutes. So that's it for now. So thank you very much. And in next session, we'll look at how to address purchasing, and we'll also look at waste management. And at the end of every training, I just want to say some special thanks to the individuals who have facilitated today's training. And you can see contact for ILAE and FutureNeuro and my own contact if you have any questions. Thank you.